Hi, welcome to our video presentation on the automated smart greenhouse system with rain fail safe feature using Arduino Uno. So our group consists of four people, which is me, Arman, and Megat, Hafiz, and also Emirul. So this project tackles the challenges faced by greenhouse managers, especially in regions like Malaysia, which there are heavy rainfall that can lead to over irrigation and flooding of our farm. So our goal was to automate greenhouse management, ensuring optimal conditions for plant growth while incorporating a rain fail-safe feature to protect the system during adverse weather conditions. So right now, let's dive into the system's design and functionality.
Hello and Assalamualaikum. My name is Emil Aiman bin Saiful Amin, student ID 21000018, and I'm going to talk about the system overview. Now, let's start by explaining the components and how the system works. The first is the microcontroller, which is the Arduino Uno that serves as the brain of the system. Next is the sensors. The first sensor is the rain sensor, which is actually a switch which will be manually turned on if there is rain to trigger the fail-safe mechanism. The second sensor is the soil moisture sensor, which monitors the water level in the soil to manage irrigation. The third sensor is the temperature sensor, which ensures the greenhouse remains within the desired temperature range. And the last sensor is the a light sensor, which determines the intensity of natural light and activates artificial light when needed. There is also three actuators, which is the first, the water pump. The water pump irrigates the soil based on moisture levels. The second actuator is the fan, which manages ventilation, turning on and off based on temperature thresholds. And the last actuator is the LED and a buzzer, which provide visual and audio feedback. There is also a main switch, which is the master control switch. If this switch is turned off, then all of the function will be turned off as well. In addition to that, there is also two push button, which will be manually controlled if we want to override the system. All components are powered by batteries, and the system has been programmed to operate autonomously, responding dynamically to environmental changes.
Hi, my name is Muhammad Hafiz bin Harun Al Rashid. My student ID is 22000307. And I will be demonstrating about our first feature of the greenhouse system project, which is the rain fail-safe mechanism. Okay, so we have this switch right here, which we use. Wait, okay, this is the rain sensor, which we use a slide switch to replicate a rain sensor because in Tinkercad there is no rain sensor. Okay, so this is switched on, and if it is switched off it will be on the left side. Okay, this is our water pump and this is our ventilation fan. This is the red LED. Okay, so whenever rain is detected, it will immediately turn off this water pump, it will turn off this ventilation fan, while also turning on this red LED simultaneously. It is to indicate that rain is detected. Okay, now I will demonstrate on how it works. Okay, the system is ready. If we look at our serial monitor, okay, let's say there is no rain. So the red LED will be turned off. I'm sorry, it's a bit laggy. Um, okay, the red LED is turned off. Okay, and the water pump will start moving because the soil moisture here is very dry. Okay, now the water pump is moving. Okay, so when rain is detected, it will send a current to this Arduino Uno because it detects raindrops, and after that it will turn off this water pump and also this ventilation fan and turn on this red LED as you can see right here. Okay, so now the water pump will be turned off, but it is a bit lagging. Okay, now it is turned off. As you can see on the serial monitor, it says rain detected, fan and water pump are turned off, indicating that there is rain. It is because the switch is on. Now I will turn off the switch. So this whole system is to prevent any over irrigation to our greenhouse system and to prevent any system damage. This will further ensures that our greenhouse system will remain safe under rainy conditions. Now I will start the simulation. So this is it for our rain fail-safe mechanism.
Hi. So in our automated greenhouse system, the this LM36 temperature sensor plays a crucial role in monitoring the temperature inside the greenhouse. Based on the temperature reading from the sensor, the system controls the fan to maintain an optimal environment for plant growth. We have set two temperature thresholds, which is below 35 and above 40. So for below 35, when we have to start the simulation, when the temperature is below 35, so it will stop immediately. It is considered to be in a safe and comfortable range for most plants. In this case, the fan is turned off, which help conserve energy. But when it is above 40, the environment inside the greenhouse can become too hot for the plants, which could lead to stress or even damage. To address this, the fan automatically turns on to help cool the environment by expelling the warm air and bringing in cooler air. So why is this important? The fan only runs when it's necessary, which helps in conserving energy and reducing operational costs. So it will save the energy. For plant health, by maintaining a stable and comfortable temperature for the plants, the system ensures that they are neither too hot nor too cold, promoting health growth. So, in conclusion, the temperature-based fan control is a key feature of our greenhouse automation system. It ensures the plants remain in an optimal environment by regulating the temperature through smart fan control while also helping to minimize energy usage. Now, we will show you the irrigation system controlled by the soil moisture sensor. As you can see, there are a few components that we use, such as soil moisture sensor, power supply, DC motor, which is a water pump, relay, and also two LED, which is connected to the resistor. The green LED will indicate us that the soil moisture is low, and the green LED will provide us as an indicator to tell us that the soil moisture is sufficiently moist. So, as you can see, when the soil moisture level drop below 30%, the water pump will automatically turn on to irrigate the plants. As you can see, the soil moisture now is 0%. So once the moisture level exceeds 40%, the pump will automatically shut off. And now I will demonstrate it. As you can see right now, the orange LED is turned on because of the low moisture in the soil. Now I will increase it slowly until it reaches 40%. As you can see, it is 46% right now, and the motor automatically stops from pumping more water, and the LED turns into green to show us that the moisture is sufficiently enough. So this feature ensures the plants get the right amount of water without overwatering it or making the soil become too dry and too harsh for the plants to live in that condition.
Okay, let's move on to the next feature of our greenhouse system, which is the light intensity sensor. So we have this right here. Okay, this is what we implement into our project. Let's run this code to see how it works. Okay, so this is our light intensity sensor. We use a photoresistor. Okay, we assume that if the light intensity is below 40%, then it is insufficient light for the crops to grow, to undergo photosynthesis. As we can see, the light intensity is zero on the serial monitor and also on the LCD. Okay, let's wait. Okay, it is zero. All right. So the artificial light will be activated for photosynthesis. Let's increase the light intensity. Okay, now the yellow LED brightens up according to this intensity. So now the artificial light is turned on. Is turned off. I'm sorry. It is turned off because there is now enough light for the crops. We can see that it is now 86%, which is above 40%. So this shows that this feature works well in our greenhouse system, and it is actually important to implement because we need to ensure that our crops receive adequate light for photosynthesis to optimize growth.
Lastly, let's look at the LCD display and manual control. First, I'm going to start the simulation. The LCD shows real-time data, including light intensity, temperature, and soil moisture levels. This keeps users informed about the greenhouse current state. As you can see over here, the LCD displays all the data that you need. The manual buttons provide override control for the pump and fan. So, this is the coding for the LCD. And there is also a coding for each of the sensors. Now, if I push this button, the fan will be manually turned on and it will be displayed on the LCD. As you can see, there is fan on manual. It is the same for this button which acts as a manual button for water pump.
In conclusion, our automated smart greenhouse system integrates multiple sensors and actuators to automated key greenhouse management risks. With features like temperature control, soil moisture based irrigation, and a rainfall safe mechanism, this system is a step forward in sustainable and efficient agriculture. Thank you.